Okay, now let's look at another example here. It says that this is g of x is equal to the square root of 2 plus x in my numerator and 3 minus x in my denominator. So we finally get an example that I've been alluding to in previous examples about how we have to pay a little bit more attention to our numerator now for rational functions when it relates to finding the domain. So since we have a square root in the numerator, well, we just can't ignore the numerator this time, because remember, the only values for a square root function that are valid will be those for those up under the radicand or the radical that would be non-negative. So we've got to find out, we got to solve two parts here this time for our domain. The first thing we would like to consider is we would want to say, where is 2 plus x greater than or equal to 0? Alright, and this simply tells me that x has to be greater than or equal to negative 2. X has to be greater than or equal to negative 2 in order for my domain to make sense in my numerator. Okay, now also we have to be concerned again in our denominator, those values of x that will make our domain or our denominator be 0. All values of x, which we should be able to easily see that the real number 3 is the only value of x that will make our denominator be 0. Okay, so now, but we have to be careful here. So let's just go ahead and solve that. 3 minus x equal to 0. This says that negative x is equal to negative 3. Therefore, x is equal to 3. So now, so that means we don't want 3. We do not want 3. Okay? We want everything else except 3. Okay? But so now we've got to tie in some facts here. Okay? The numerator says that the only values of x that you can use will be those greater than or equal to negative 2. And we've got to honor that. We've got to respect that. Meaning, if you try to go and find a value that's not greater than or equal to negative 2, let's say negative 1. Okay? Let's say negative, let me see. Well, I'm sorry. Let's say negative 3. I was totally thinking wrong. If you find something that's not greater than or equal to negative 2, like negative 3, if you plug it into this numerator here, you're going to have a negative value under the square root symbol, which you can't do on the real line system. Even though negative 3 is a part of the domain for the denominator. See, the denominator says we don't want positive 3. So if we don't want positive 3, that means that we want everything from negative infinity up to 3, union 3 to infinity. Okay? So, but what we've got to realize here is that when we looked at the example for negative 3, okay, even though negative 3 is actually in this interval right here, negative 3 is in this interval, we cannot use this in our domain because it violates this guy. See, negative 3 is not greater than or equal to negative 2. So we have to only respect those values that are greater than or equal to negative 2, but we've got to throw out 3. We can't have 3. So my domain would be the set of all x such that x is greater than or equal to negative 2, but x does not equal 3. That's the only thing that you can do for your domain. You cannot include all of these values from negative infinity up until 3, because some of those values will violate x being greater than or equal to negative 2. And that's from negative infinity all the way up to negative 2, to negative 1 actually. So I hope that this actually makes sense to you. You have to consider both parts of your denominator here. Both parts. This is a very good example to study. Very good example to study. So rehearse it.